So with a lot of the enzymes that are, reactions that we see in these metabolic pathways are redox reactions. And we have studied these before, but we're going to review the meaning or the definition of oxidation and reduction before talking about these coenzymes. And these are basically electron carriers. Oxidation, the inorganic definition, is a loss of electrons. For reduction, the inorganic definition is the gain of electrons. And we have looked at this too early on in the semester. However, now that we're focusing on organic types of reactions, the definition for oxidation is loss of hydrogen or gain of oxygen. And these are specifically carbon to oxygen bonds. Reduction, on the other hand, is the gain of hydrogen or the loss of carbon to oxygen bonds. And in our metabolic pathways, these redox reactions require a coenzyme, and this coenzyme acts as an oxidizing agent. And if you recall, oxidizing agents are reduced. So these coenzymes get reduced in the process of these reactions. So when this coenzyme acts as an oxidizing agent, it gains hydrogen ions, or H+, and electrons. Think back to our definition of reduction: gain of hydrogen, gain of electrons. When the coenzyme, after it's been reduced, then can act as a reducing agent, causing a reduction to occur. Sorry, I wasn't reading this appropriately. So the coenzyme then is oxidized. So there are going to be two forms of these coenzymes: the oxidized form and the reduced form. So NAD+ is the oxidized form, and as it acts as an oxidizing agent, it gets reduced to NADH, and then NADH can be oxidized back to NAD+. So when that coenzyme acts as a reducing agent, it gets oxidized and it loses a proton and an electron. So this is a reversible process. Here's the structure of nicotinamide adenine dinucleotide. That is the actual name of NAD+. It's a mouthful, so we typically call it NAD+ rather than nicotinamide adenine dinucleotide. Dinucleotide, and it has two phosphates here. Here's that ribose. Here's our adenine. And here is the point at which NAD+ gets reduced. So this carbon right here. And in the next slide, you'll see what that looks like. So this carbon lost a double bond. This is now NADH. We've added that hydrogen here and two electrons. So this is the reduced form of NAD+ or NAD+. So here is a reaction from the citric acid cycle. and it's the conversion of isocitrate to oxalosuccinate. So this is a redox reaction, and when we have these coenzymes in a reaction or required for a reaction, it's conventional to show them like this. So a curved arrow that hits the forward arrow. So here we have our NAD+, that's the oxidized form. It gets reduced, and we also have a proton here. So remember, it's going to pick up a hydrogen ion and 2 electrons. And this carbon-oxygen bond, so remember, this is getting reduced, so this gets oxidized. And we are increasing the number of carbon to oxygen bonds. So that was oxidized to oxalosuccinate. Okay. This is another coenzyme, FAD, or flavin adenine dinucleotide. It is also an oxidizing agent. So here's the oxidized form, and this is the reduced form. And it functions just like NAD+. So again, it's a relatively large molecule, flavin adenine dinucleotide. This nitrogen, actually we're going to have 2 regions of reduction here that you'll see in the next slide, or 2 things reduced. Both of these nitrogens lose a double bond and form a bond with a hydrogen. So after gaining 2 protons and 2 electrons, this is FADH2, the reduced form of FAD. So FAD is made from vitamin B2, which is riboflavin. It has a yellow color. It's a water-soluble vitamin. We get it from our diet, from green vegetables, leafy green vegetables, soybeans, almond, liver. And because this is water-soluble, if we ingest large quantities, the excess amounts are excreted in urine, and that might give it a bright yellow appearance. However, this type of these water-soluble vitamins don't build up in fatty tissue because they are water-soluble. Thus, if you consume too much, it's just excreted in your urine. So here's a table that just summarizes the coenzymes that we just looked at. NAD plus in its oxidized form, NADH in its reduced form, FAD and FADH2, giving their roles and their full names. And you should be familiar with these. Here's coenzyme A. We encountered that when talking about acetyl-CoA being a product of the breakdown of lipids or fats, carbohydrates, and amino acids, but we had not yet actually looked at the enzyme itself. It is not an oxidizing or a reducing agent, but it is a carrier of 2 carbon units in the acetyl-CoA molecule, and it has its reactive end here is a thiol group. And if you recall, when we looked at acetyl-CoA, the acetyl group was bonded to this thiol group. We had a thioester bond here, but as you can see, this is a big molecule as well. Very important. So more on coenzyme A, and I just said this on the prior slide, and we looked at this when we looked at metabolism. There is a thioester, and that comes from that reaction between that carbon group and this thiol group. So we get this thioester linkage.